our solution is going to be to search through the root items sub-items for an item that has the same tree that we're currently looking for. So this is based on the fact that value trees are wrappers to a reference counted object. If they have the same set of properties and values, they are going to be the same value tree. So let's move over here to TaskQueue item.cpp, and let's start by getting rid of the old approach. So just block comment this out for right now. And with that code gone, we can begin. So we need to get the root item of the tree view via getOwnerView, and it's going to get called a few times. So let's DRY it. So we'll do that right below our selected trees. Auto owner view equals getOwnerView. And it's a good idea to make sure it exists for whatever reason, that we're not like some weird node that doesn't have an owner view. Make sure it's not a null pointer. And then let's replace the usage here. And here. And also here. All right, now we can grab the root item. So we'll do that down here. If auto root equals, and we'll cast it, dynamic cast TaskQueue item pointer, and we want to do owner view get root item. Oops. And our job now is to find the TaskQueue item with moved tree as its tree member. So let's write a static function that will search the tree items. To do that, we'll just go auto node to select equals, and we'll just say there's a member function that we can use, find TQI with tree root and then moved tree. So what we're going to do is we're just going to call this for now. We're going to implement it in just a moment, but it's going to search through the root. It's going to search through it recursively. It's going to search through all of these TaskQueue items recursively until it finds this. And if it finds it, cool. And actually, we'll wrap this in an if, like that. Wrap that in if. If we find a node to select, then we can do node to select set selected true, like that. All right, let's move over to our header file. And let's add a static function after our get selected tree view items. Here we'll go static TaskQueue item pointer, and now we'll do this guy right here, this function, and we'll say it takes one of these as a node, and it takes a value tree to find. So we'll do const value tree reference tree to find. All right, now we've got our declaration in place, and now we can do our implementation. So let's put that above our move item. Put that right here. Okay. TaskQueue item pointer, fully qualified name, find TQI with tree, node, const value tree reference tree to find. And now we can write our algorithm to recursively find the TaskQueue item with our drag and dropped tree. So first, if we get an empty node, just bail. If node equals null pointer, return a null pointer. Let's debug what we're looking for with our indenter. And we'll say make name node get tree. And for this to work, we're going to need to actually have a getter function because tree is private and this is a static function. We'll say we're looking for something. Make name tree to find. We'll do something like that. All right, let's add our getter over here. Value tree get tree return tree. Oh, am I missing? I am missing a closing parentheses. Okay, so let's check. If node get tree equals tree to find, then we can just return the node because the node is the one that we're looking for. Return node. Otherwise, if it has child nodes, we need to check them. If node get num sub items is greater than 0, if it's got children. Actually, we don't even need to do this. We can just do for int I equals 0, I is less than node get num sub items plus I. Now we can loop through them. So each one is a candidate, so we can do auto candidate equals node get sub item I. And actually we need to normally get sub item returns a tree view item, and we actually need it to return a TaskQueue item, so we'll do the same casting thing that we had before. And let's wrap this in an if. If we can do this cast. So if we're able to do this cast, like for whatever reason, maybe we modify our tree a bit and some items are not TaskQueue items and some items are TaskQueue items. If we're able to convert it to a TaskQueue item, then we can check to see if we can basically call this and it'll execute this line. So we can say if auto result equals call this thing, and we'll say run it with candidate and run it with the tree that we're looking for. If we get a result, as in if we returned a node, then we can just return that, return result. Otherwise, we didn't find anything, so return null pointer. All right, does that make sense? Hopefully that makes sense. We're gonna loop through all the children, and if we can convert one of these sub nodes into a TaskQueue item, then we're gonna call the recursive function on it because it already has the code to check if the trees match. So if we find that the tree of this child matches the tree that we're looking for, we're gonna return that. That's gonna go here, we're gonna return this, and then that's gonna give us our node to selected here, and then we're gonna select our node. Okay, so let's try it out. Oh, my fault, this should be moved tree. Oh, and I'm missing a parentheses there. And a couple other parentheses were also missing. Or I had extra ones. All right, linking. And build succeeded, running. All right, let's add 3 nodes and see what we get. And we'll drag this here. Oh, we have our breakpoint. Let's uncheck that breakpoint and continue. Hey, look at that, it's still selected. Awesome, works as expected. All right, and if we look through here, we can see item dropped. This is good to go, and we can see where is our looking for, TaskQueue tree looking for, task2, task 0 looking for, and then task 2 looking for. Okay, so it worked. Excellent. Okay, let's add a few more tasks to this and do some more testing of the drag and drop just to make sure it's cool. And a bunch of these guys. Add some task is not implemented yet, so let's not worry about that. Okay, we'll just drag this. We'll put it, remember task 6 is selected. We'll add it as a node to task 0. So we get up, still selected. Let's do 3, put it in between them. Still selected. Task 0, let's make it a child of task 1. Still selected. Awesome. I have a pretty good feeling that this is still good to go. Let's do 6 as a child of 1. Awesome. All right, I'm satisfied. This solution works.